Hello, everyone. Here we are in Chapter 1, Section 1 of our textbook. This is a case study, and this screencast will help you make your way through the textbook. It is based on slides that you can also consult that are on the RStudio server. So what you should do, as we've learned from our previous screencasts in covering a unit, is when you're working with the screencast, you want to open up the slides so that you can work along with them, and stop the screencast from time to time to try out things for yourself in RStudio. So here I am in RStudio, and I would like to open up the slides for this case study. So as we have learned to do, we head over to the dots where I'm waving my mouse, and we click on it, and then we say /COM. And then we say OK. And it may take a moment, but eventually the server will show you all the folders in the common folder, and you go to Dr. White stuff, and Mat 111, and the slides. And you look for the Section 1.1 Open Intro Statistics slides, OS 1.1 Case Study slides. Click that blue text, and between these two options, you want to choose View in Web Browser. And they'll pop up for you. Wonderful. Okay. Let's begin. This is a case study involving some data on a medical experiment involving stents and stroke. So what are you going to need in order to follow along with these slides? Well, in RStudio, you're going to want to make sure that your R session has access to the functions and the data sets in two packages, Open Intro and Tigerstats. And so you're going to want to make sure that those two commands that you see there on the slides are run. So you can copy and paste them. Copy. And then you can come over to the RStudio, and you can make sure that your console is available and on top, and at the blue prompt, you just make sure that your mouse is active there, and Control V on Windows or Command V on a Mac pastes in the two commands, and you run them. And you may not get all that output that I'm getting. I often restart my R session, and so I have to reload my packages. Whereas in previous exercises, you may have already loaded those packages, and they'll be in your R session unless you take specific steps to unload them. So head back to the slides. Stents to prevent stroke. Here's what they say about this case in the textbook. They say stents are devices that are put inside blood vessels that assist in patient recovery after cardiac events, heart attacks, things like that. And they reduce the risk of an additional heart attack or death from some kind of heart problems. And one time, there were a lot of doctors that hoped that there would be similar benefits for patients who were at risk of other stuff like strokes. And so doctors had a research question. Does the use of stents reduce the risk of stroke for people? And they set up an experiment to investigate the question. Now we're going to go into experiments in more detail in a later chapter. So this is just a quick blow-by of this one. What they did was they went to people who were at risk for stroke and asked them if they wanted to be part of an experiment. And they got 451 people to volunteer. And what you have to do in order to actually get people to volunteer is you have to tell them what the rules of the experiment are going to be. And these were the rules. If you agreed to join the experiment, you were going to be placed randomly, just by a chance process, into one of two groups. The first group's called here the treatment group. Okay, and if you got into this group, you were going to receive a stent and some medical management for that stent. Whereas if you were randomly placed into the control group, then nothing special happened to you. You would just get the same kind of medical management that people who are at risk for strokes get, but you're not going to get a stent. Usually that's the way the terminology goes. The treatment group is having the special interesting thing done to them. The control group is treated kind of like how medical practice usually works today. And once the people were in the two groups, then researchers, just medically managed them and waited a year to see who in this experiment would have a stroke. So the results are in a data set that are in that open intro package that we've got loaded. And that data set is called Stent 365. I guess 365 means they waited a year. So we want to learn about it. And the way that you learn about data sets that are in our packages is you ask for help on them and you ask to view them. So I'm going to run both of these commands. So I'll copy, Control-C on Windows, Command-C on Mac. Head to RStudio. Make sure that my cursor is flashing next to the blue prompt in the R console. Paste in. Here are my two commands. And press Enter. And they run. And the help brought up this in the Help tab over here in the lower left-hand corner. And I'm just going to go to this little button, Show in New Window that you see there. And I'm just going to flash it up big for us to see here, just for a moment. And so there's a description of where this data set came from, why it's there. So it's an experiment that studies effectiveness of stents in treating patients at risk of stroke. And it had some unexpected results. We'll see what those are in a minute. These data represent the results 365 days after the stroke. Sometimes help can be a little bit technical, like why do they have this usage section and what in the world is a tibble? But if you just hang with it, you can still get a lot of help from the help. What's really nice is that it tells you the names of the two variables in the data set, group and outcome, and it tells you what they mean. Group is a factor with levels, control, and treatment. Outcome is a factor with levels, no event, and stroke. And there's some other interesting information at the bottom where you can get more, background on the data set if you want. Okay, what's all this about factor? What do I mean by variables? Let's figure that out by maybe heading back to the view here in RStudio. So what we're looking at here in the editor upper left-hand corner is now a view of the Stents 365 data set. So kind of like an Excel file would show you a view of the data set. And sure enough, there's the two variables, group and outcome. And when they said group was a factor, they're meaning that it's a kind of variable that's not numbers, it just gives different names for groups. The treatment group and the control group. Every row here is a person who's in the experiment. And that first variable group is saying whether they were in the treatment group or the control group. So our first person was in the treatment group. And the next variable, outcome, says what happened to them by the end of the year. This person had a stroke sometime in that first year. The second person was also in the treatment group and had a stroke. And you can go on down and you can see other types of, like this person 46 here was in the treatment group, but they did not have a stroke. And that's symbolized by no event over in the outcome variable. And if you go down further, then you can see people who were not in the treatment group. So you might have to scroll down quite a while. Oh, here we are, like person 260. They're in the control group, and this person did not have a stroke. Okay? So you always want to take that time. Take that time to run help, run view, whenever you're confronted with a new data set. in this class. And take that time to kind of go slowly through it all. Belabor it. Think about what each row means. And here it means each row's person who's in the experiment. And what the columns mean, and what their values are, and how they're spelled even, is going to be important for learning to work with the data. Okay, so we've done a pretty good job there of learning about the data. And this slide just kind of summarizes what we've learned. Every row was a patient, and then there were these two variables. So what we want to do next is to begin to analyze the data. And this is where we use the R language to ask it, to do various types of analysis. And now don't worry too much about the computer code here. You'll learn more about why it is the way it is in later chapters. Just be confident now that if you just follow along, things are going to be okay, and you will be led to understand what you need to understand at this point. So what's happening here is you're going to make R do a tally, a count up of what happened to the people in the two different experimental groups, the treatment and the control. And it's going to produce this table down here. So we're not going to worry right now about all the stuff inside that makes that happen. We're just going to make it happen ourselves by copying this command, heading back to RStudio, and paste it into the console and run it. And here we go. In the console, we see that same table. So what we want to do now is study the table, learn how to read it, see what it means, and what it's telling us. For that, I'm going to go ahead and head back to the slides. So the columns here talk about the two different treatment groups. The control group, where people just didn't have any stents, and the treatment group, where they did. And the bottom of the column, those are the total number of people in each group. We can tell that because of the word total here. So 227 people were randomly placed into the control group, and 224 of the volunteers were randomly placed into the treatment group. The other rows say what happened to the people in each of the groups. No event, that means no stroke. Well, 199 out of these 227 people had no stroke. On the other hand, see the 28 next to the stroke here? 28 out of the 227 people in the control group did have a stroke. That's how this table works, how you can read off what's happening to the people from the numbers. So what we would like to do with that data is to make an estimate for the risk of stroke if you don't have a stent, and the risk of stroke if you do have a stent. First, let's start with not having a stent. So we use the control group for that. So we say, well, look, we want to find the proportion of people in the control group that had a stroke. So in our minds, the formula is stroke divided by total. So that's going to be the 28 people that we saw in that table that had the stroke in the control group over the 227, the total people in that control group. That's the proportion. And if you multiply proportions by 100, then you get percent. And you would get 12.33%. Now, if you're using R like a calculator, which I recommend that you practice a lot doing, then you would just say 28 divided by 227 star 100. So to model that here, I'm just going to do it. I'm going to copy, paste, 12.33%. Okay, so My best guess, based on the data, is that if I'm an at-risk person and I don't have a stent, I have a 12% chance of a stroke in the coming year. Well, what if I'm in the treatment group? What if I got a stent? Well, you can go back to the table and check it out. Under treatment, we see 45 of those people had a stroke out of a total of 224. So in our computations, we'll do 45 divided by 224 times 100. If we use R like a calculator, that would be written like this in the console, and you would get 20.08%. I invite you to stop the screencast and try it yourself. But I'm going to go ahead and go on. The key thing I'm seeing here is the difference in those percentages. It really looks like having a stent increases your risk of stroke. 12% chance with no stent, 20% chance with a stent. It's an 8% difference. It's an almost double difference, 20, almost double at 12. So this was quite a surprise for the researchers. Now, there is an important question that remains, though. This difference that we saw in the data, 20% versus 12%, is that really due to whether or not people had the stents? Or could that difference have arisen just by chance variation in which patients got into which group? Because when you start with these 451 people, they're not all going to have the same outcomes. Some of them really are at more risk for stroke than others. Some of them are much worse off than others. And what if just by chance, the people who were really going to have the strokes, just by chance happen to usually more often get placed into that treatment group where there's stents? And so, then if that's what's going on, then it's not the stents that's making them have the strokes. It's, it's just because they were already worse off anyway. So is the difference real due to the stent use? Or is that observed difference reasonably explainable as just chance variation in the process by which we got this data? That's what we call an inferential question, as opposed to a descriptive question that we just answered looking at the data. And we're going to learn to answer the inferential question in a later chapter, but I'll bring it up now because it's important and because you need to be always thinking ahead to that kind of question. So fairly short topic here. And so this brings us to thinking about the DA that go along with these slides. I'm not always going to do this as the course goes on and on. I'll do it less and less, but I want to take some time out to introduce you to the DA so that I'm kind of modeling how you would think about things when you're starting off with DA, how you connect that with the slides and what you read in the textbook. So when you open up the DA, you're going to find that you need to learn about a new data set. And so you're going to be wanting to run the help and the view commands on that new data set that's called Youth Risk 03. And so let's go ahead and do that now. Let's head back to our studio. And let's grab the DA. So let me go over to Files and see where my Files pane is pointed right now. It's in COM, Dr. White Stuff, Mat 111, Slides. I'll go back to Mat 111 by clicking on that, and then I'll click on DA. And I'll open up OS 1.1 Case Study RMD. And remember how we've been taught from our previous practice section, immediately we want to save this DA to our submit folder back in our home directory. And so I head right away to File, Save As. And right now the dialog box has me looking back into that same DA directory in that common folder where I cannot store anything. And so I want to push the ... And I want to say that twiddles that they tell me about here to head back to my home directory. And then inside my home directory, I want to look for my submit folder. There it is. And I want to click on it twice, a little double click. And that gets me looking inside of it. Make sure you're looking at home and then submit. And then this file name here, you want to keep that file name, that original file name. You don't want to change it. So all you got to do is say save. And now, remember, this buffer you're looking at here for the DA is a buffer for the DA that you have saved in your home directory. Changes you make here in that editor pane, if you save them, will save into your submit, right? Your DA in your submit folder, and I'll be able to see them. I'll be able to see your work. So now that I've actually opened up the slides and opened up the DA, I'm just going to, over here in the files pane, I'm going to go home there as well. I always like to end the day looking at, my home folder. And I'm going to do a further check. And I encourage you to do this as well. Look through your home folder and make sure that your DA is not saved right there at the top, but instead click briefly into your submit folder and see that the DA is there. And sure enough, OS 1.1 case study RNDA is inside your submit. Great. You can click back on home now. Okay, now back to where we were with the slides. I'll go ahead and put my name. And I'll just go past all that CSS styling we talked about. And we see the part where we need to learn about the data set. And this little R code chunk actually has these commands in it that we were supposed to run to learn about youth risk 03. So if you want, you don't have to copy paste in the console. You could just click the little arrow there that says run current chunk, and that'll do you the courtesy of copying and pasting from the R Markdown document into the console and running those commands. And so now you see the help for Youth Risk 203 here, and you see the view here, and it's kind of temporarily squashed the console down. I like to have a little bit of console, so I'll click on that bar and bring it up. And you can see where it, sure enough, copied in those two commands to the console. And so you want to learn about it. And what you will learn is by reading the help and by reading this file, is by reading this view, is that every row is a student, a high school student, who was interviewed as part of a big study about some of their safety behaviors. And so like this first person here, they were a male, that was one variable. And they were asked about their grades, like what kind of grades they usually got. And they were asked some other questions. And one of them that they were asked was, how much do you use sunscreen? And they were able to respond from everything from like a never to essentially all the time when they're out in the sun. And they were asked about their grades like in another way, or maybe the researchers categorized them in another way. This grades 1 here is categorizes things as to mostly A's and B's, mostly C's, or mostly D's and F's. Whereas the grades here, this first row is much more specific about the grades. What else do we need to do? When you read the DA, you're going to learn that your primary research question is there any relationship between how much one uses sunscreen, as reflected in that sunscreen variable, and one's grades? So that's what you're going to be taking with you as you go into the DA. Heading back to the DA itself here, I'm going to go ahead and knit it up so we can get a good look at it. And I'll pop it up big in the browser. And you can see that this is kind of the setup work that it's asking you to do that we've been addressing somewhat here in the screencast. And then there's questions. There's a making a two-way table question. And, well, actually, sorry, there's a setup where they ask you to make a two-way table. And there's another section where they're going to give you questions about it. And each of those questions you're going to enter a response to in a certain place in the DA. So how about this making a two-way table? To make a two-way table of students' responses to the question about sunscreen use and their grades, please run the following R code. Tally, grades 1 versus sunscreen. And when you knitted up the DA, it went ahead and ran that code, so you can actually see it right here. You can see the table right here in the DA. And studying that table, you could then start answering these questions pretty much in the same way that you studied the stents table and answered some of those questions in the slides. And if you like to look more directly at the R Markdown document, remember you can do that as well. So like you could go to the making two-way table part. And you could actually run the code chunk for the tally right here and see the table stuck here for you in the this little bit of output. And you could read from it as well as you answer these questions. So you can choose whichever approach is more easy in a given moment, looking at the knitted version or looking at the R Markdown. But one way or another, you can answer these questions. And I'm just gonna, I know we've practiced this before, but I just want to do it one more time. Let's just answer the first question, just to practice how to do it. How many students who never used sunscreen got mostly A's and B's? Okay. 1 never, 2 rarely, 3 sometimes, 4 most times, 5 always. Okay, so those are the different types of answers they gave. And this down here next to total, there's 1188. 1,188 out of the several thousand students that were asked this question said they never used sunscreen. How many of them got mostly A's and B's? That's what the question's asking us. And so the answer is that 747 that I've just highlighted. And so you can go down to the answer section that goes with this question, and you can eliminate that text there and just say 747 of them got mostly A's and B's. There you go. You've answered a question. I suggest saving your work. So Control S or Command S is the easiest way, so that there's no more asterisk after the end of the file name up here where I'm waving my mouse. Your answers are now recorded in a way that when the homework is collected, I'll be able to see them. Remember, you can also save by knitting, and that's a good thing to do to check to make sure that the document still looks nice. Well, that's enough of a help into the DA. go ahead and continue to work on it. And I'll see you another time.